Bismillah Rahman Rahim. In this session, we will discuss question number 8 to 10 from topic trigonometry, that is exam exercise 9.10 from additional mathematics course. This book is written by Sue Pemberton. This book is very popular. And here we have question number 8 first, part A. Given that 15 cos square theta plus 2 sin square theta is equal to 7, we have to show that if this relationship is true, then tangent square theta is equal to 8 upon 5. So we will take this equation and we will obtain tangent square theta from this equation. So 15 cos square theta plus 2 sin square theta is equal to 7. This cos square theta can be break down into 13 cos square theta plus 2 cos square theta. So this is 15. So as a result, we will obtain this cos square theta, sin square theta. We take common 2 here, and then sin square theta plus cos square theta in a bracket becomes 1. So this part becomes 2 only, because sin square theta plus cos square theta is equal to 1. We take 2 common from this and it becomes 1. So this is 2. Now this 13 cos square theta is plus 2 is equal to 7. So 13 cos square theta is equal to 5, because this 2 could be placed on the right hand side, and negative minus 2. So 7 minus 2 is 5. So we can write down this cos square theta on the other side. So 13 is equal to 5 cos square theta. Simple manipulation. 13 is equal to 5 cosec square theta. 13 is equal to, this is 13, this is nothing, 1 3. So this is 15. 1 plus tangent square theta. 13 is equal to 5. This is plus 5 tangent square theta, and 13 minus 5 is 8, and 5 tangent square theta. So tangent square theta is equal to 8 upon 5. So we have taken this equation and we have obtained this relationship. This is simple. We can also easily obtain this thing, so but we have taken this steps to obtain this. Tangent square theta is equal to 8. This is part A. And now we are solve 15 cos square theta plus 2 sin square theta is equal to 7 for 0 to pi radian. So we have to solve this equation. So we have to obtain theta value where this left hand side is equal to right hand side. So we have to obtain the value of theta where it satisfies this equation. That is our solution. So 15 cos square theta plus 2 sin square theta is equivalent to tangent square theta is equal to 8 upon 5. So this is we have already solved it in a part A. So from the part A we can write down as a tangent square theta or tangent theta is equal to plus minus under root 8 upon 5. So this tangent square theta 8 upon 5 under root. So we can write it in a positive and a negative term. So when we take this inverse, this is positive in first quadrant and third quadrant. And similarly, this is negative in second quadrant and fourth quadrant. This is fourth quadrant, this is second quadrant. So the solutions are this is second quadrant and this is third quadrant, because we have to take value of theta from 0 to pi in a first and second quadrant. So the solution in the first quadrant and solution in the second quadrant. So the solutions are 0.9 and 2.24. So in order to check that we have obtained correct solution, I have draw the graph to show the result that these two values are our solutions. So this is our solution. We have just plotted it. It is not required in final examination or any kind of examination, just for better understanding of this problem or an idea or concept, to improve the concept, to build the concept, we have drawn this graph. So I have drawn this 15 cos square theta plus 2 sin square theta. We take the values of theta from 0 to pi and plotted it. From 0 to pi, this is pi. From 0 to pi we have plotted this and equate it with 7. So this is 7. And we see that it is intersecting at this point and this point. So these are our solutions. Our two solutions are 0.9 and 2.24. We can see it from here. This is 0.5, this is 1, and this is 0.9. So this is our first solution and this is our 2.24. From here to here at the middle point, here we have 2.24. So we have two solutions. So we have drawn it and proved that our solution is correct. So this kind of plotting helps to understand the concept of this question. So what is the purpose of this solve? Solve to obtain the value of theta where this equation satisfies. The value of theta is, this is value of theta, because this value of theta is 0.9, or value of theta, this is theta, radians. So this is our solution. Now we have question number, we have solved question number 8, part A and B. Now question number 9. We have given this graph. The diagram shows a sketch of the curve y is equal to a sine bx plus c for the range of 0 to 180 degrees. So this is 0, this is 180 degree, and find the value of this a, b and c. From the graph we have to evaluate the value of a. This is coefficient, this is magnitude, and this is the period. The b is gives the period, the number of period it has. If it is 1 from this to this, so this value is gives the number of period, and this c is basically the intercept, because this, if this c is 0, this graph will shift, this point will shift here and it will oscillate. But c, since c is intercept, so it's quite evident that c is 7, between 6 and 8. So this value is 7. So this c can be seen from here, it's 7, and we are just doing it. The maximum value is 10. So this function maximum value is 10 and function minimum value is 4. This is 4. So we take the difference, and this is 10 minus 4, and if we divide, it gives the magnitude from reference. This is our reference, so we can see that the difference is 3. So the amplitude is 3. So this gives 3. A is equal to 3. This is our magnitude of this function. And now b, we can see the bx. This is this should be equals to 360 degree. So bx is equal to 360 degree. So this is completed within how many periods? From here to here, and after that it is repeating here, second, from here to here is third, and from here to here is fourth. So there are 4 periods here in a 180 degree. So 4x is equal to 180 degree. So 4x is 180 degree. So bx is equal to 360 degree. So x is 45. So this is from here to here it is 45, from here to here is 90, this from here 135, and from 135 to this. So from here to here it is just a 45 degree. So in a just 45 degrees, so B is obtained as 8. So there are 8 periods in a 360 cycles. So 180 it is only just 4. So in 360 it becomes double. So the period of this cycle from 0 degree to 360 degree, it becomes 8 periods. So here in for 0 to 180 degree we have 4 periods. And this is period 1, here period 2 completed, here period 3 completed, and here period 4 completed. Starting point to the end point and then repeating. Then here afterward it's repeating. From here to here it's repeating. From here to here it's repeating. For 0 to 180 degree 4 times repeating. For 0 to 360 degree 8 times repeating. So the period is 8. So that's why the B is 8. Now this is intercepting from 0 position to this value. So this is 7. So C is 7. So we have obtained A, B and C. And we have plotted it, and we see this in a fair drawings. We have plotted this 3 sine 8x plus 7, and our results are obtained this. So this 3, 8 and 7, A, B and C. It's evident like this. Now part B, given that fx is equal to 5 cos x plus 1 for all x, state the period of f. So this is the period. So 3x is equal to 360 degree means x is equal to 120 degree. So this is simple. The period of this function is 120 degree. And this is the magnitude. Amplitude is 5. So it's 5. And the intercept is 1. So intercept is 1. So we have plotted this 5 cos 3x plus 1, and we can see that from here to here one period is completed and it is available at 120 degree. And we can see that the intercept is from maximum to minimum. So this is 6 minus 4, 10 divided by 2. So f maximum is 6, f minimum is minus 4, f max minus f min is equal to 10. 6 minus minus 4 becomes 6 plus 4 is equal to 10 divided by 2. So it becomes 5. So this is 5. This is amplitude. So this is very easy. I have plotted it so that it can be explained. In a final examination, we are just required this one. This is just for understanding, for practice, for better understanding for other problems. This is building the concept. Now question number 10, we have this is question 8 and 9. So here in this session we are discussing question number 8 to 10. So let's take the question number 10 here. We have given 4 sin x is equal to cosec x for the range of 0 to 360 degree. So 4 sin x is equal to cosec x. So this is 4 sin x is equal to this is 1 over sin x. So this from manipulation 4 sin square x minus 1 is equal to 0. So 4 sin square x minus 1 is equal to 0. 2 sin x minus 1 square. So this is a square, this is b square, a minus b square. So a minus b and a plus b is equal to 0. So we have either this is 0 or this is 0. So if this part is 0, then x is 2 sin x is equal to 1 and x is equal to sine inverse half. For this part we have this one and x is equal to sine inverse minus half. So this is positive half, this is exist or lie in quadrant 1 and quadrant 2. And sine is positive in quadrant 1 and quadrant 2, and sine is negative in quadrant 3 and quadrant 4. So we can see that this half value is 30 degree and 150 degree. So x is obtained as 30 degree and 150 degree. From here we have minus half is at 270 degree and 330 degree. So we can write down in a sequential way. So 30, 150, 210 and 330. So these are the solution for this equation. So this was required, and we have just plotted it for understanding. So we have two equations. So 4 sin x, we have plotted 4 sin x on one side and cosec x on the other. So this is this red graph is cosec x, and this blue is 4 sin x. So this is 4 sin x. So that's why its magnitude is this. And we can see that it is intersecting at these points here, here, here and here. So at 30 degree, here we have 30 degree, we have one solution. At 150 we have another solution. At 210 we have third solution, and at 330 we have fourth solution. So these all are available here. We're just plotting it. Just gives the concept that why we have this 4 solution. Now this equation is very simple, so we can understand that how number of solution for this range for 0 to 360 degree. So here we have plotted value of x or theta, whatever, for 0 to 360 degree, and we can see that the number of intersecting points are our solutions. So this is our solution. This is part question number 10, part A. So this solution is easy, and we have to solve up till here, but this is just for my better, just to give the concept, so that why we have this 4 solution. So this is why, that's why there are 4 solutions. So I'm just showing it graphically. It is not required in an exam. I'm just giving it some concept. So when one has a better idea whenever, because in a final examination everybody sees unseen questions where this concepts helps to answer so many questions. Now part B, we have to solve tangent square 3y minus 2 sec 3y minus 2 is equal to 0 for the range of 0 to 180 degrees. So this is tangent square 3y can be write down as a sec square 3y minus 1, and from this we have this sec square 3y minus 2 this, and from this we have factorize it, and from factorization we have this part equals to 0, this part equal to 0. From this part sec this cos 3y is equal to 1 over 3, 3y is equal to cos inverse 1 over 3, and we have to obtain 180 degree because this is 3y, so we will take it to 3 times. So that's why we are taking higher ranges, because it will divide by 3 to give a value within a band. Similarly for this one, this is negative, and cos is negative in the second and third quadrant, and positive in first and fourth quadrant, and this is repeating. So we have obtained these values for 3y. These are the values where the range is this, and y is obtained by, because we will divide it by 3. So after dividing, the value of y is 143.15, that is within 0 to 180 degree. So we'll take it 3y up to 3 times 180 degree. So that's why we have taken this solution. Now y is this, and now this 3y. So y is 60 degree, 180 degree. Now we write down in a sequential. So 3.51, this is 60 degree, 96.5 degree, 143.1 degree, 180 degree. So these are the solutions, and now we are plotting it. We are just plotting this 3 tangent square 3y minus 2 sec 3y minus 2. We have plotted it, and this is 0, and we see that it is intersecting at this value. This is 23.151 here. This is the first solution, and it also intersecting at 60 degree here, 60 degree, and 95.5 degree here. We have this 96.5 degree, and again here at 143.51 degree here, 143.51 degree, and at this point 180 degree. So this gives a better idea, because why we have this so many solutions. We have just plotted this graph and it equate it with the 0. So we have plotted this graph with a combination of all these terms. We have drawn this. We have plotted. We have solved this all these terms with a calculator or some Excel plots or any other plotting methods. So we have obtained these values against for different values of y, and plotted it and compare it with a 0, and we have obtained these intersecting points. So there are 5 solutions, which is evident from here. So it gives understanding and confidence, so that we can solve it, these kind of questions in final examination. Now part C, we have given tangent z minus pi by 3 is equal to under root 3 for 0 to 2 pi radians. So x or z minus pi by 3 is equal to tangent inverse under root 3. So we will take this pi by 3, 4 pi by 3, 7 pi by 3. So 7 pi by 3 here. Now x is minus pi by 3 is this, so we will shift this pi by 3 on the right hand side, so it will add with all 1. So when we add this pi by 3 to this one, and this one, so this is 2 pi by 3, this becomes 5 pi by 3, and this becomes 8 pi by 3, which is beyond this 2 pi. So we will discard this one because this is more than 2 pi. So we have these 2 solutions. So solutions are 2 pi by 3 and 5 pi by 3. Now we are plotting this tangent z minus pi by 3 and equate it with under root 3. So this is under root 3. This black line is under root 3, and we have plotted this tangent z minus pi by 3 here. This tangent, this red and blue lines are tangents for this 0 to this range and for the others range. It is intersecting at these 2 points. So here the first solution is 2 pi by 3. So this is 2 pi by 3, and the second is 5 pi by 3 here at this 5 pi by 3. So this is a very important question, and which is a part of the final examination, 3 marks question in IGCSE additional mathematics course. So appeared in this was the part of June 2015, and in the next session we will solve question number 11 and 12.